So our next speaker, Francois Nivart, is founder and leader of Image Matters, specializing in digital imaging, which has led him into the product design for digital cinema, broadcast, and industrial vision equipment.
Okay, waiting for my presentation. Well, I have to say that I'm a little bit nervous today because I've been extremely impressed by the different presentations this week, and particularly to the evolution toward artificial intelligence, toward cloud-based working, cloud-based computing, and also about the needs of evolution of the picture, of the image. Image is continuously evolving. When I started, we were discussing about 2K in digital cinema, and here we were discussing about 8K picture. We came from 24 frames, and then we are now at 120 or up to 240 frames. And when we discuss about virtual reality, we are going even much further. And we are far away from what we will be discussing in about 10 years from now, when we will be discussing about volumetric display, where the quantity of data is evolving extremely fast. So it's interesting to approach the topic of image, which is the topic that is mattering to us, and to go forward and to see how we can support that by a hardware evolution. So what we do at Image Matters, we do hardware. We do hardware modules, and we are much more attached to the architecture of the system than attached to the function. Obviously, we are attached to the functions of the system, but in the context of how can we support what you are going to do with your picture? How can we support what you are going to process, how you're going to process your picture? So one of the things we have to observe in picture, it's extremely large stream. We are not discussing about a document. We are discussing about a documentary. We are discussing about something that is much heavier than just a piece of paper. And this is the reason why we need to be connected. Even in the cloud, we are struggling with in and out. Secondly, we need to process the picture very heavily by different means. And the processing of the picture is evolving even faster and faster. What we've just seen requires a lot of processing and a lot of analysis too. In the cloud, we started with the virtual machine. Virtual machine is basically an emulation of a computer. Good, but what's for? Because we like to have multiple computers on a single machine, on a single hardware. When we are progressing, we see that basically we are attached to the PC-based box concept in the cloud. The box, the 19-inch rack appliance, are basically PCs that did evolve toward being a server, then to be virtual machine, and more recently to get GPU acceleration in it, and finally to have more recently again a trend toward FPGA acceleration. The reason of that evolution is efficiency. We have more data to process, whatever it's picture or anything or other data. We have more data, and we need more efficient processing for that. We are more connected. We need more networking. And when we consider the CPU are great, but the GPU are about 4 times more efficient, 4 to 8 times more efficient. And when we do consider FPGA, which are even closer to the gate, we are even more 4 to 10 times more efficient than GPU. So the transition between CPU and GPU when the quantity of data to process is increasing is about a factor of 10 to 20. So it's very important in terms of power consumption, in terms of capacity also. What do we need? We need a ton of function, and as we just seen, it's evolving continuously. We come from routing, encoding, decoding, which is our usual things, to packaging, analyzing, recognizing, extracting, editing. Everything is now on the cloud. When we see the hardware side, the FPGA-based hardware, we have a lot of people that are specialized in one function, specialized in encoding, JPEG 2000 encoding, MPEG encoding, HEVC encoding, or specialized in one function, input, output, how to interface. And these are a few of them that we could have listed. There are a lot of them that could be listed. They are specialized and they are very efficient in implementing in hardware the function they target. The second thing is the interconnection. We need, when we do accelerate the picture, processing or analyzing or anything, we need a lot of picture access. We need very strong interface. And if we go back to the model of the cloud, usually we are limited by this shape. We are limited by this access due through the CPU. FPGA, GPU are just seen as accelerator for the CPU process. It's true or not true. If you have a look to the architecture of the Microsoft appliance, they do interface now directly to the cloud without passing through the processor. But it's important for us, in order to unleash the capacity we want to see from the cloud, it's very important to have a very strong connection to the cloud. So when we speak about virtual FPGA resources, what we are thinking, we are doing the same analogy to the virtual machine. We want to emulate an FPGA and to have multiple FPGA functions implemented in a single FPGA. You could also reverse it. We want to be able to use multiple FPGAs to provide more functionalities, more power to one function. So it's one-to-many or many-to-one between the FPGA resource and the function. Okay, what we select on our side is to take a modular approach. So what we developed is a small module. This is the real size. This is a powerful module. This module is capable to do up to 8K 120 frames per second for 12 bits with TICO compression. Not only to do it, but also to interface it in and out. And this is as small as this. But the interface here is not specified. Where we specify the interface is on the baseboard, is on the carrier board. For instance, here I just mentioned SDI and Ethernet interface. It could be also a PCI Express interface going to a usual server. And inside the FPGA, it's interesting to implement the different functions, as any FPGA programmer do, usually relating to different IP cores that they are assembling in order to make the full data path inside the FPGA. Where we are unleashing the power of the FPGA is when we could combine a very high dense appliance with a lot of FPGA together, processing power of FPGA. And I do have here a mock-up of an appliance where we combine 8 FPGAs on a single 1U short rack unit. So you could increase the processing power you have available to you by combining multiple small modules, and we have very small modules, we have larger modules with Virtex, with Kintex, and with very small FPGA too. So there are really modularity behind, and if you could combine them into a very compact and power efficient appliance, you enter into a new world in leveraging the FPGA, the hardware processing. This is particularly true when you are looking toward the artificial intelligence, where the inference of the artificial intelligence is particularly well done with FPGA comparing to GPU or CPU. It's highly efficient, power-wise, and it's somewhere what we will have to apply most of the time. So this is basically the message for me today, is just to say that we are facing an increase of processing power and needs and requirements for processing power that we are unfaced till now, and we are facing for a high connectivity. And what's about the high connectivity in this appliance? Every module is interconnect with the other module, not in a full mesh network, but every module is interconnect to the other module of the appliance, so you could exchange data between the modules. And secondly, the modules are connected to the front face toward Ethernet. What is interesting is that the front face of this appliance is SFP cages, which is good for internet connection, since you could validate different kind of interface. But you may also interconnect direct SDI. If you are not in the cloud in a data center, but if you are in an OB van or on-prem or on-set, it's interesting to be able to connect directly cameras to an FPGA resource to do, for instance, an SDI to SMPTE 2110 gateway. And this is very easy to do in this case, and you don't need any computer. It could be used, obviously you may use box, small boxes to do that. But here you have an appliance that could be anything you need, and from set to set, from case to case, you could reconfigure it easily. And this is what I mean. It's what if we have to go with the box out of the cloud? If we leave the data center and we go back to the premises, we go back to the set, we go back to the embedded devices, if you go back to the camera, what you have developed and the technology you would be able to manage on an FPGA could be leveraged from the camera down to the cloud. So it would be very nice to have a face recognition device in a camera that has been powered and developed on the cloud, but inferred in a camera module where you could tell where your actor, automatically your characters are appearing on the screen, or doing speech recognition directly with the power of the cloud, but locally applied to your device. So this is the target of the modular approach. The same architecture could apply from embedded up to the data center. And this is my message for today. Thank you.